The code for this video will be available in the description below. Hello everyone, welcome to my channel. Today we will talk about how to generate artificial data using a cluster generation package in R. It is a very good package that allows you to generate data for your own simulations. So let's see how it works. So firstly, we need to source the package by doing library cluster generation. Inside package cluster generation, I have a function called gen random class, which generates a cluster, and that cluster will have 4 classes. So basically, data points belonging to 4 classes or 4 memberships. So class 1, class 2, class 3, class 4. And then you can set the separability value defined as sep_wall. This separability value can range between negative 0.999 and positive 0.999. It is used to indicate how separable your data points are. The higher it is, the more separable your data points are. So you will have more distinctive classes. So class 1, class 2, class 3, class 4 will be very different from each other. If you have a high separability value, if you have a low separability value, those 4 classes will be very similar to each other. And then you can specify the number of non-noisy or useful variables, descriptive variables or independent variables for your data, as well as the number of noisy variables. So in this case, I set the number of non-noisy variables to 10 and number of noisy variables to 5. And then you can set outliers in your data. In this case, I'm assuming no outlier in my case, and later on I can change it to show the effect of the existence of outliers. And then we will output data into a file called test, and we will see later how it works. And then we have this parameter called class size int. So it's a pointer value. If it is 1, then all classes will have the same number of instances. So let's say, for example, if the total sample size in your data is 500 and you have 4 classes, if you set this class size int to 1, you will have 500 divided by 4, 125 rows of data for each class. So 125 cases of class 1, 125 classes of 125 cases of class 2, sorry, 125 cases of class 3, 125 cases of class 4. If I set it to 3, like I do right now, I would have to indicate the cluster sizes. So basically the number of cases for each class. So in this case, we have 50 cases for class 1, 50 cases for class 2, 75 cases for class 3, 300 cases for class 4. So this is what we call an imbalanced data set. And then you will also have this cluster size equal to what? This number, as suggested in the documentation for this package, you should set this number to 10 times the total number of variables. So in this case, we have 10 non-noisy variables, 5 noisy variables, in total 15 variables. So 10 times 15, 150. Obviously, the higher it is, the better it is. And then you will have a bunch of parameters. I suggest keeping them exactly the same as what they have in their package documentations. And then you will have this output data flag. If you set it to true, it will produce and save. a bunch of data lists. If you set it to false, it will not save them. And the output log flag, similarly, if you set it to true, it will create a log for what's going on. If you set it to false, you won't have anything exactly. And those two output empirical, output info, it doesn't really matter. If you don't want to keep track of your data, just set them to false. It will save some memory. So let's run it, see how it works. So, okay, now I have a object. My cluster is a list of 5 objects. So let's take a look at the data. There are 2 useful things. One is the class membership, accessible via my cluster mem list, and then test1. Okay. So it will give me a bunch of classes. So indicating the membership of each row of data, and then we have the real metrics of the data. So this will be the independent variables for my data. As discussed before, in total I have 10 non-noisy variables, 5 noisy variables, so we have 15 variables in total. And how many data points we have? Well, we have 50 plus 50 plus 75 plus 300. So that's 475 rows of data. So indeed, we have 475 rows of data. So what we can do, we can put it into a data frame for easy viewing. Let me just call it mydf data frame my cluster mem list test1 my cluster dat list test1. Okay, and then let's view my df. So this is much nicer. So the first row of data is a class 3 object. It has these variables for description of it and so on. So this is a nice data frame. So let me close this. So previously I set my output dat flag to output log flag, output empirical flag, output info flag to be true, and that's why I got a bunch of files here. If you don't want to have these files, what you can do is just let's delete all of them for now. Clean the environment and then just set them to false, and you won't have anything. So this. Okay. So save it, run it. So if I run it like this, I won't have any files being saved. So again, let's just create a data frame of what's going on. Okay, so again, we have this. And also, we mentioned earlier that there are 5 variables. So 5 of x1, x2, x3, all the way to x15 are noisy variables. How do we know which 5 of them are noisy variables? Well, that is easy. You just do my cluster noisy list test1, and it will tell you is the second, the fourth, the fifth, the 11th, and the 12th variables are the noisy ones. So that's basically how it works. And also, if you want to create multiple data sets, what you can do is to change this number of replicates to, let's say, 3 if you want 3 data sets. So let's run it, see how it works. So if I do this, I have the ability to create multiple data sets, in this case 3 data sets. So I can have a data frame called mydf from my cluster memlist test1, my cluster datlist test1, and I can have a second data frame because I have generated 3 data sets. So I can have another one or another one, test2, so in this case I have 2. I can create a third one if I want. So far we have talked about how to create data sets with no outliers. So what about creating data sets with outliers? So we can do number of outliers equal to 100, let's say. What that will do is it will create 100 data points that are outliers. So let's see how it works. So let's extract the data from it. Actually, I can just do this. So view df. As you can see, we will have 575 entries, 575 rows. This is different from the sum of the number of representations, number of cases of all 4 classes, which is 475. That's because we added 100 outliers. So we have 475 plus 100, which equals to 575 rows of data. So over here, we have the non-outliers. So each of them have a distinct class membership, class 1 to class 2, class 3, class 4. But if we go all the way down, we will have these outliers characterized by class membership of 0. So that's how it works. That's pretty much it. Thank you guys for watching.